Hi folks, it is really cold outside here in Zanesville, Ohio right now. What a perfect time to talk about a warm-up program for your machine to keep it in good condition and treat that spindle and machine really well. This video is going to cover two different warm-up routines. The first is only for a spindle warm-up. We're going to walk through how you can take this to customize your own warm-up spindle routine with variables. It's pretty awesome stuff. And then the second is a warm-up routine that does both the spindle and uses your machine home position to automatically locate it and move the machine through its maximum travel extents. Welcome to another Wednesday Widget. So first up, we're going to go through spindle only. If you want to jump forward to the warm-up routine, we've got the time posted right here where you can skip forward. Anyone watching this channel knows that I'm a CNC guy, I'm a CAM guy, I'm not a manual G-code guy. Nevertheless, I think most folks that have been around a machine shop for a while using CAM will recognize things like M3, which turns your spindle on, and S1000, which would rotate it at 1000 RPM. You may not know a command G04. That's a pause or a dwell. And on Tormach's Path Pilot, if we did something like G04 P10, that would pause the machine for 10 seconds. So this bit of code right here would be perfect for a warm-up routine. It would turn our spindle on at the RPMs that we wanted, pause for that long, and then we could write the next line, M3, I don't even know if you need the M3 again, S2000, G04, P10, and so on. But that's no fun. First of all, I don't write code. And second of all, I want something cooler. I want something that's more powerful, more variable. This is what we came up with. Now, here's what's awesome about this. If you don't care about anything I'm about to tell you, don't worry. You can use this without having to understand all this nitty-gritty. But I'll tell you, for the folks out there that love diving in and starting to learn how awesome and cool things like using variables when you program are, stick around. This is fun. This stuff gets me fired up. So how do you use this code in your Tormach? If we take a look, if you right-click and edit the number of loops, you can say, I want it to run 7 times. And if I change my starting RPM, let's start it at 500. Increment, 500 is fine. And the time in seconds, let's say we want it to be 100 seconds for each cycle range. Don't need to change the current RPM. You're done. You could customize this. You could even create different ones. You can have a quick one and a long one so that depending on the weather outside or time of year, you can run different spindle warm-up routines easily. So much fun. And yes, folks, absolutely, you could handwrite this code. In the end, you're getting handwritten code. But for me, I love having it in Fusion. I can share it with other people. I can edit it. Frankly, I know where the code is, so I can repost it when I need to. To me, awesome stuff. Let's dive into how we can use Excel to help us as a tool here. I like to jot down notes, either on paper, which is totally fine, or in this case, in Excel. So what do we want this code to do? This is so helpful to me. Forget about programming. Just think what we want it to do. The goal here is to warm up the spindle. And if you've seen other warm-up programs, it's, again, what we just did. Runs the spindle at a starting RPM for a certain period of time. Well, I want that to loop or increment up each time. So when I thought about this code, I said, okay, I want to loop through X times. X meaning I want to be able to control how many loops it does, and I want to be able to control the increment of each loop. So do I want it to increment up each loop by 50 RPMs or 500 RPMs? We need to control what RPM it starts at. And then finally, how long is it going to stay on at each RPM? I'll be honest, I don't usually run warm-up routines. Our shop is heated. It doesn't get that cold. It still would be a great idea. So what's nice about this is we could easily change our warm-up routine. Let's say you need to get going. You only want to run a 3 or 4 minute warm-up routine. That might be fine in our shop. But if your shop's in the basement or a garage and it's unheated and it gets down to, say, 50 degrees Fahrenheit, that's 10 degrees Celsius, it's probably worth taking the time to run a longer spindle warm-up routine. After that, I start thinking about the variables that I need. And I never get this right the first time, but that's okay. So we know we need the number of cycles. That's the number of times it's going to loop through this code. We know we need the starting RPM, and we know we need the incremental RPM. How much is it going to bump up the RPMs each time? I didn't think I needed this until I started writing this code. So let's look at the output of that code. We're going to cheat. The way this code reads is number of cycles is 5. So we're going to do 5 loops. We're going to start the RPMs at 250. We're going to increment Each time it does a loop, it's going to bump it up by another 500. So the second loop would be 500 plus 250 or 750, 1250 thereafter. What's the warm-up time for each one? I've got it right now at 200. The 200 seconds, or a little over 3 minutes. That's the same in metric. And then this is the one I didn't think I needed. We'll come back to that. So to loop in PathPilot, aka Linux CNC, we have this command here, O105 repeat. Normally I would write that O, note that's O, not 0, 105 repeat, and I would just say bracket 10. I would write my code, that's G code, and then I would, at the very end, I would say O105 and repeat. So the difference is that instead of having a bracket 10 end bracket here, we've got a bracket pound and then that variable. It's the exact same thing I typed up here. So that's referencing the variable that we set above. So that means this code between here and here is going to get looped the number of cycles, or 5 times. Awesome. M3, you recognize that. And then the same thing. Instead of typing S250, we're typing S, and then I'm just referencing what would have been that starting RPM. We actually need to use the current RPM, because when we first loop through it, you would think it's the starting RPM. But what we actually want to do is, bear with me here, we're going to then pause by the spindle warm-up time. You guys are getting this by now, I'm sure. Then we say the current RPM is going to equal the current RPM plus the increment. So let's walk through this once. We know we're starting at 250. We told it that. So nothing here, nothing here. Ooh, current RPM equals starting RPM. So that means current RPM is set, that variable is set to 250. Now the only stuff that repeats is the stuff in here. So this stuff doesn't happen again. So the first time it sees the M3, current RPM is set to 250. Delays for the number of seconds. Then current RPM of 250 equals 250 plus 500. So now current RPM is 750. So it loops back up to right here, and it's going to run it at 750. We're done. 2 last quirks. If you're trying to do this with your Tormach post processor and it doesn't work, click on the card here to make a very quick post processor change that allows this manual type pass through to work, so that we can actually pass through manual G code with the manual NC function in Fusion 360. A very, very easy change to do. We walk through it in that video. The second quirky thing is that unfortunately right now, hoping to get this changed, Fusion will not post only manual NC comments. We have to post a toolpath. Well, I don't want the machine to move. This is supposed to be a spindle only routine, so it's unacceptable to me that we're telling the machine to move whatsoever. So what I did is I added a trace operation in here that only moves a short period of time, but it never gets there, because right before that trace, we're adding a manual NC pass-through of M30. M30 ends the program. So what happens is that when we post this code, it's actually not going to look like what I showed you a minute ago. It's not going to have the spacing between each line, so it's a little harder to read, and it's going to have this trace command, but it never gets there, because as soon as the G code sees at M30, it says game over, I'm stopping the code. Awesome. The last thing, and we're really going to nerd out now, is I wanted in the same Excel file, by the way, this is free to download on the NYC CNC website, where we've got this Fusion file as well as this Excel file. I wanted a max RPM check, because I don't really want to run my warm-up routine and blow through my max RPM. So on the Tormach 1100, that's 5140. So if we put in our variables here, let's say we're running 10 cycles, 500 RPMs, and we're incrementing, say, 750 each time. Well, the 3 last cycles are going to blow through our max RPM. So, it actually won't be a problem. PathPilot will just flash up an error, but it'll still run the spindle. But nevertheless, I want to have that not do that. So we're going to do some super nerdy Excel stuff right now. Don't feel intimidated. You don't have to do this. But if you're going to get into any sort of programming, this stuff's super helpful to use. So to start, I want Excel to show me how many cycles that I have listed right here. So how do you get Excel to change that list from 3 to 5 to 10? Let's start over and build it from scratch. My color code, and this is pretty conventional if you talk to other Excel nerds, my color code is that blue are inputs, and then green are sort of like, hey, these are abnormal cells or strange cells, so pay attention to what they do. So blue is just an input. That's our first cycle. That could be blue or frankly green. And then RPM is linked back to starting RPM. So instead of typing 500 here, it's actually equal to C5. Now, if you notice, my C5 had these dollar signs. Those dollar signs means that cell is locked. So if I were to copy and paste it down, it keeps reference to C5. If you didn't have those dollar signs there, when you drag it down or paste it down, it's going to increment C6, C7, C8, C9, etc. So we have it what's called sort of locked. You can toggle through those by hitting F4, by the way. So my next cycle would really be equal to this cycle plus 1. So we're done, right? Well, the problem with that is that it's going to show cycles 11, 12, 13, 14, 15, which, not the end of the world, but I want it to be cool. I don't want it to show a cycle if we only have 10 listed here. So what I'm going to do is I'm going to say equals if the cycle above it plus 1, incrementing up, if that's less than or equal, I might get this wrong, but we'll fix it if we do. If it's less than or equal to the number of cycles, then go ahead and show that math. So I'll retype it, B21 plus 1. If it's not true, I'm going to say parentheses out of cycles, just to show you guys what's really happening here behind the scenes, and parentheses. So, okay, I'll delete everything here below it, and I'll paste that down. So 3, 4, 5, 6. Awesome. So it worked for cycle, what would have been cycle 6. Oh, I got some problems. Okay, good. It's good to have problems. So what happened was, I can tell you right now, I didn't lock that C4. So let's walk through that first formula again. If B21, that's the cycle before, plus 1, so we now have a value of 2. If 2 is less than or equal to C4, that's the total number of cycles. So if we're on cycle 2 out of 10, we're good to go. Go ahead and show that cycle. So do that math. B21 plus 1 is 2. Otherwise, if you don't meet that condition, say you're out of cycles. So that works there. The problem I did was on the next row, it moved the reference from here down to the next one. So that's when we want to lock that C4 in place. So we're good through 6, 7, 8, 9, 10. So we're good through 10, and even what would have been 11 works, but 12, we're going to get this value error, and that's really annoying. And what the problem with that is, it's trying to do a math comparison of saying out of cycles plus 1, but you can't add text and numbers. So the way you fix that is, and this is getting super nerdy in Excel, or actually pretty advanced, but you say equals if error. If that whole thing is an error, then go ahead and just say out of cycles error. So no, same. Everything's going to be the same, including 11, but 12 is going to trigger that different thing, out of cycles error. Now, what we do is, instead of saying out of cycles, we replace that with a space. Now, normally putting spaces in is kind of bad Excel etiquette, but I'm okay with it here. So instead of showing anything, we're just going to put an empty cell in there. So now, and I'll push this down, some distance down, so that no matter how many cycles that we have 13, it shows 13. If we have 5, it shows 5. Awesome. So what's the resulting RPM? Well, on cycle 1, it was 500. Cycle 2 will be 500 plus the increment. Now, I want to keep that increment locked, so I'll hit F4 to lock it. So every time it's going to add the cell above it plus 750. So I don't want those to be green. Black is my preference. So I'm just going to paste that to the next one. Perfect. So this works, right? Well, not really, because the math is correct, but the problem is that here it's going to keep adding values. So what we would do is, I would normally fill that out to match how many down, 118. Obviously, we're not going to run 118 cycles, but that's just the way to do it. Excel is not a database, but a lot of times we make it act like one. So what I wanted to do is to stop showing the RPM when we're out of cycles. So let's delete that. So let's do this. Type equals if, open paren, if that cell for cycle 2, which is B22, if it's less than or greater than what? I'm going to put in that space. So quote, space, quote. So what did I just do there? I'm saying if the cycle number, in this case 2, but I'm worried about when it goes blank, if it's not equal to the space, then I want to count the cycle. So I'm going to say the B21 or the previous cycle's RPM plus the increment F4. And if that value is false, what does that mean? That means if the logic test was false, which means that the B22 is equal to the space. So if it's equal to the space, I don't want anything. I should be able to type that, which is just put in another space. There's some other things you can do. You can actually leave it blank, but we'll do it that way for now. So now let's paste this down. Through 5 it works. What happens when we get to the 6th value? Paste. It looks like nothing. It actually is something. And just to show that, I'll say out of cycles, exclamation point. So math, numbers, RPMs, out of cycles. Awesome. So we're good. Change that back to a 0, or to space rather. So the last thing I did, and again, super nerd, and I love it, is I have max machine RPM. It's fun to have Excel tell you when you've got a problem. So what would happen right now is if we ran 10 cycles, we're going to blow through our Spindle RPM max on the last 3 cycles. So having Excel pop up in something like red font is really helpful. So by having this value here, and this doesn't matter for the Fusion, this is only for the Excel, what I can do is I can select all of those cells that we just allowed to be RPM values. I can go up to conditional formatting, highlight cells, greater than. Format cells that are greater than. Well, I don't want a hard code value, I want to link it back. So what this does is it looks through this list, and if any cell has a value greater than my max RPM, light red fill with dark red text. Works for me. So cool. So we drop this down to 500. We're good. 625, not good. Now I don't like this particular style because it shows this red for empty values. So what I will do is change that conditional formatting greater than, and we'll just change to a custom format, make it red, bold. Now we see in bold red when we've got a problem. So we back that down to 600, nope, 550, 525, 500, there we're good. Awesome. So the important thing is in the bottom right, you see 500, 1,000. You can see it incrementing up right here. Warming up your spindle is for sure important, and arguably the most important, because spindles really matter in your machines, and when they're cold, it can be a problem. But warming up your whole machine is also important for the obvious reasons, like helping distribute the whey oil. But the other thing is it's actually really good to listen to your machine when you're not cutting. You'd be able to hear if something doesn't sound right or doesn't seem right. So what I wanted was a smart warm-up routine. So what we've done in Fusion, again, you can download this file on the NYC CNC website. Go into Modify, Change Parameters. Put in your x-axis travel. I've got an 18 inches on my Tormach 1100, and my y-axis 9.5. We'll change it just for the sake of this example. They say 14 and 8. I think that's what a 770 is offhand. Click OK. Just changed the size of that box. Hop back into Cam, regenerate. What this is doing is it's doing some toolpaths that move around the maximum travel extent of your machine. But that wasn't actually super easy to do. At least I couldn't figure out an easy way to do it unless you use this code. If you just jumped forward to this section of the video, to make these pass-through comments work, where we're actually passing through G-code in our manual NC commands, you've got to make this quick post-processor modification, or you might check if the Tormach post is updated at some point. It may include this, but link in the video description to showing it very, very easy to add this little blurb, 5 or 6 lines of code to your post-processor so that this stuff works. So what does it do? Let me post it out and we'll walk through it. You'll notice too, by the way, what's really cool is when I'm posting it, I'm at my office desk in another section of the shop right now. I am writing this to the actual PathPilot controller, which I've mapped as a network drive card here to walking through how we can use PathPilot with either map network drives or Dropbox. So most of this code is the actual cam operations that are causing the machine to move around the maximum travel range. That's boring. This is what I care about. Let's walk through this. Anything in parentheses is just a comment, has no bearing on what the controller is doing. Some standard sort of G-code header stuff. Working in inches, tool height. First thing is pull manual oiler handle. You'll notice a comment and then M0. To tie that back to Fusion, I have a comment here, and it's just that. Literally, it's a comment, pull manual oiler handle. Looks like it doesn't pass through exclamation points. Everyone knows I enjoy exclamation points. And then I have the next line is a manual type stop. So what that does, when you hit cycle start with this program, the first thing it's going to do is stop. It's literally going to just stop. Now, unfortunately, this comment can get kind of lost in the mix if you're not looking for it, so it's not the perfect process, but the machine's not going to move forward until you hit cycle start. And so we've learned at our shop that if something does that, the first thing you do is look at what the code says, and you'll be able to see pull manual oiler handle. Joking aside, one reason I like exclamation points is they're not things that are used in normal post-processor or machine code, so that tells me it was something that we did or we wrote. Next, we pass through G58. So this was just my choice. This is very user dependent, but generally I don't use the G58 work coordinate system. So I like that because we're about to change the G58 XYZ0, and I wouldn't want to do that to an offset that I use. For example, if I've got a program set it in G54 or G55 and I don't want to lose my coordinate system, I don't want to overwrite that coordinate system just to run a warm-up routine. There are more even higher that we could write to. Important thing to know here about G58 is that if we put in a comment here, G54, G55, G56, G57, G58 is the 1, 2, 3, 4, 5th offset, and that matters when we get to this line. First, we're going to do a G0, Z negative 1.5. So that's going to move to location of Z negative 1.5, but from what? Well, from G53, which is the machine's home position. So it's going to move to 1.5 inches off the Z home position, which is the same as where your Z would hit the soft limit or hard limit switch. Basically 1.5 inches lower than the top of your Z. What we then do here is so cool. This goes back to Wednesday widget 144 when we were testing speeds and feeds, and I wanted the Y offset to automatically update so that I could just keep hitting cycle start and taking another 50 thou off the piece of material while I was adjusting things like the RPM and feed rate. So what does this do? G10, L20, P5, Z0. Short answer is it says that the current position is going to be Z0 for offset P5. That's 1, 2, 3, 4, 5. So G58, Z0 is the current position. So what we're going to do is run this machine warm-up routine at Z negative 1.5. As long as you don't have a long tool or any tool in your spindle, it shouldn't hit any of your vices or fixtures, but that is really important when you run any warm-up routine, is making sure it's totally free and clear to do so without crashing. We then do a very similar move, G53 move to X0, Y0. So this is going to look like your machine is moving to its reference or home position. And then when we get there, set that not equal to 0, but slightly off 0. Y positive 0.25, X negative 0.25. This just gives us a little cushion and a buffer from running to the exact extreme limits. You could push it out further if you like. You could do more of this on one line of code. I think breaking it out into a few separate lines makes it easier to digest. After that, we run a contour, which walks around the part, the sort of box of your extreme XY limits. We do a G30, that just sends the machine home, so you're getting a little bit of Z-axis motion in here. Not a ton. I don't like the idea of programming too much Z movement because it is important to do, but I don't want the risk of crashing your machine with our code. Then we do a trace, which is going to do a little bit of a different diagonal motion. You should be pulling the oil handler maybe once more throughout this, and then back to a contour. You could do this at a slightly higher spindle speed if you like. And that's what you can do. You can adjust the RPMs, and if you want to run these longer, you could either change the cutting feed rate, or you could just check multiple finishing passes to have it walk around numerous times. As programmed right now, this is about an 8-minute warm-up cycle. Again, edit it as you see fit to have it go as long as you need to go. And we're working right now on revamping our maintenance program, our maintenance recommendations to you. Things like tram are important, adjusting your gibs are important. 9 times out of 10, if it's April or July or November or the shop's 50, 60 degrees Fahrenheit, I go make parts. I don't worry about running a 10-minute warm-up routine. The spindle, especially if it's cold, is something I would focus more on. Folks, I hope you learned something. I hope you enjoyed. What I love about this is make your machines work for you. Yes, we need to do maintenance, and it's fun to do maintenance on a schedule that's planned, so you don't have to stress about it in the uncertainty, but really go make parts, go enjoy, go have fun. This reminds me too of the Business of Machining podcast that I do with John Grimshaw, where we're always thinking about how do we do it better and how do we do it smarter, and again, kind of how do we get the machines to work for us. So I hope you learned something, hope you enjoyed, take care, see you soon.